All right, so in the last section, we learned how to find the maxima and minima using calculus techniques. So we introduced the idea of critical points. Remember, you have a critical point. You first have your function, then your function has critical points whenever your derivative is equal to 0 or your derivative is undefined. Okay, now we're going to talk about applications of maxima and minima. So applications involve word problems here, and the goal here is to find the optimal or best value. So in other words, we want to find the largest or smallest possible sum possible of some quantity. For example, we want to find the greatest possible profit or the lowest cost. Things like that. Like what would be the better buy? So these types of problems are called optimization problems. These are called optimization problems. You might want to have page 1 where you can look at it over and over again whenever we're going through the examples here. The first thing when you're given such a problem is to make sure you read and understand it. Then identify your unknowns. This may require drawing a picture and labeling the parts that are important in the problem. The second thing you want to do is write an equation. Write an equation for the quantity whose max or min you want. If you can, express the function as a function of a single variable, like put it all in terms of x, that type of thing. You might have to perform some type of algebra and use of information from the statement of the problem. Make sure you are aware of the domain of your function. Then you test your critical points and your endpoints, or you can use the first derivative test, whichever you prefer, but this is how you go through and find the best by the greatest possible profit or the lowest cost. Okay? So let's jump right in. We want to minimize f equals x squared plus y squared, subject to the equation xy squared equals 16. We want to minimize f equals x squared plus y squared, subject to xy squared equals 16. So here, note that x squared, and I'm going to use red. Note that x y squared equals 16 is what is called a constraint equation. That's our constraint equation. And that means y squared is equal to 16 over x. Okay? Note, you can also say x is equal to 16 over y squared if you chose to solve it for x. So that means x has to be greater than 0, right? Because if you're putting in all values of y, it's always going to come out to be greater than 0, this number. So that means x is greater than 0, which is the domain of f. Okay, so all of that, we have the domain. Now we solved for y squared. We use our constraint equation to solve for y squared. Now our goal is to minimize f equals x squared plus y squared. Well, look, we found that y squared is this, and we have a y squared here, so we can just substitute it in. Okay, so f of x can be rewritten as x squared plus 16 over x, because 16 over x is y squared. Now, if you want to rewrite it, but we're getting ready to find the derivative. So that's x squared plus 16x to the negative 1. Now we want to find f prime of x. F prime of x is equal to 2x minus 16x to the negative 2, which is the same thing as 2x minus 16 over x squared. Okay, now f prime of x, now we're minimizing, so we want to find our derivative. We found our derivative, now we find our critical points. So f prime of x equals 0. Well, when does it equal 0? That means 2x minus 16 over x squared is equal to 0, or 2x is equal to 16 over x squared. And then you can cross multiply. Think of that over 1. Cross multiply. You have 2x cubed equals 16, or that gives you x cubed, divide both sides by 2, equals 8. Now we can take the cubed root of both sides, and that gives us x is equal to 2. Now, x is equal to 2 here. Now the question is our derivative ever undefined? Is our derivative here ever undefined? Sure. It's undefined if x is equal to 0, but we don't care about that because that's not in our domain. Our domain is when x is positive, so we don't have to be concerned about 0. So x equals 2 is our critical point, okay? So x equals 2 is our critical point. Now what we're going to do, we're going to check our number line. We're going to mark our critical point. We're going to take a point to the left to check it and a point to the right. So let's choose 1 and let's choose 3. And so here we take 1. We're using the first derivative test. It's not necessary. You don't have to do that at all. You do not have to do that at all. F prime of 1 is equal to 2. We're using this portion. It's equal to 2 minus 16, which is negative 14. So it's negative. Then f prime of 3 is equal to 2 times 3 is 6, minus 16 over 3 squared is 9. So you test this and you can rewrite 6 as, you can rewrite that as 54 over 9 minus 16 over 9. Well, that gives us 38 over 9, which is positive. So we changed from negative to positive at our critical point, which was 2, which means we have an absolute minimum. So let's move this up. So we have an absolute minimum. When x is 2, so now we plug 2 into our original function. So f of 2 is equal to, this is f, the smiley face is f, so we get 2 squared plus 16 over 2. That's equal to 4 plus 8, or 12. So we get 2, 12. That's our absolute minimum. So we also need to make sure, so that's our absolute minimum, because we were asked to minimize this. But notice that we found out x was equal to 2 over here. Notice that you can also find out y using this blue cloud up here. Okay, so x is 2, so y, let's use our red one, undo. So y squared would be equal to 16 over x, or y is equal to plus or minus the square root of 16 over x. Now we're going to plug in x equals 2. So substituting x equals 2 into y gives us the following. Y is equal to plus or minus the square root of 16 over 2, which equals plus or minus the square root of 8. plus or minus the square root of 8 gives us plus or minus the square root of 4 times 2. The square root of 4 is 2. So this is equal to plus or minus 2, the square root of 2, because the square root of 4 is 2. So that's our y. So if we have x is equal to 2, that means y is equal to plus or minus 2, the square root of 2. And since we wanted to minimize it, we found that our absolute minimum is this. All right, let's try 2 more examples to make sure we are confident with this new information of optimization. Okay, so the cost in billions of dollars of airing X 5-second hologram commercials during a galactic chess game can be approximated by C of X equals 490 plus 320x plus 0.001x squared. How many hologram commercials should your company air to minimize the average cost? After we answer that, what is the resulting average cost of a 5-second ad? Round your answer to the nearest $1 billion. Okay? So, let's start by just writing down what C of X is. C of X, we can make that look better. That looks wild. So C of X is equal to 490 plus 320x plus 0.001x squared. Now we have to remember here it says that the cost in billions of dollars of airing X 5-second hologram commercials. So that's the number that we're airing, right? Now, our question says how many hologram commercials should your company air to minimize average cost? So we need to take our cost and divide it by whatever we're airing. So that would be our average cost. So make sure you understand that. So if you need to pause the video, rewind it back to hear that over again, do that. Okay? So the average cost is given by C bar of X. We normally use the bar for average. That would be equal to our cost over X because we're airing X 5-second hologram commercials. So that will be equal to 490 plus 320x plus 0.001x squared all over X. Dividing everything by X is the same thing as taking each term here and dividing it by X. And that over X. So writing that down, we get 490 over X plus 320, because 320x over X allows our X's to cancel, and then plus 0.001x, because X squared over X is equal to X. So that's how we simplify there. Now, all of that because now we want to answer how many hologram commercials should your company air to minimize the average cost. If we're minimizing the average cost, this is the formula for average cost. If we're minimizing this, we need to take the derivative of it, right? So one more step before we take the derivative, you might want to rewrite this as 490 x to the negative 1 plus 320 plus 0.001x. Well, now we want to take the derivative of that. Doing so, we get C bar of x, or C bar prime of x, is equal to, we differentiate, negative 1 times 490 is negative 490x to the negative 2, because that's negative 1 minus 1. The derivative of 320 is 0, plus the derivative of 0.001x is 0.001, because the derivative of x is 1. So That means we get our derivative is equal to negative 490 over x squared plus 0.001. Now, we found our derivative. Now we need to find our critical points. So our critical points, remember, we set our derivative equal to 0. Setting our derivative equal to 0 means that we now have negative 490 over x squared plus 0.001 equals 0, which means negative 490 over x squared is equal to negative 0.001, or in other words, we can divide both sides by a negative. That gives us 490 over x squared equals 0.001, or 0.001 times x squared equals 490. This is cross multiplying. That's cross multiplying, so you can think of that over 1 and cross multiply. Now, we now have to solve for x. Well, this means x squared is equal to 490 over 0.001. If you divide that out, you can use your calculators if you want to. I'm going to take this and go all the way up here to continue our work. Okay, so now that means 490,000, because that's what we get when we divide 490 by 0.001. That's equal to x squared, or either we take the square root of both sides, and technically you will have plus or minus, but ending up with minus here doesn't make sense. So that gives us x is equal to 700 adds. Okay, so whenever we're asked how many hologram commercials should your company air to minimize average cost, 700 ads. Okay, so we have to make sure that that indeed gives us a minimum. Well, to verify that, do your number line. That's our critical point was 700. So we have that here. Test the number to the left and to the right. You can test 659. Now we're using what test? Do you remember? Think about it. What test are we using? The first derivative test. Okay? So you test 659 and test 701. You're checking that in your derivative. Remember, you're checking that in your derivative here. So if you take a minute and check C bar prime of 659, you'll find out you're going to get a negative. So substitute that in there and check, verify it. Then if you check C bar prime of 701, then you're going to get a positive. It changes from negative to positive. Because it changes from negative to positive, that means we have a minimum. And in fact, that's our absolute minimum. So this gives us our absolute 700 is our absolute minimum. So we were asked to find, so how many holograms? 700. That's one part of our answer. Okay, that's from the absolute min. And then what is the resulting average cost of a 5-second ad? So now we need to actually plug 700 into our average cost. We need to plug 700 into this here. Okay, to see what we get. So C bar of 700 is equal to I'm going to use this one here. It's equal to 490 over 700 plus 320 plus we have 0.001 times 700 so 7 then we get this is about 0.7 plus 320 plus 0.7, which gives us 321.4, or approximately, wavy equals means approximately, $321 billion per ad. That's expensive, okay? But that's it. That's the resulting average cost of a 5-second ad. One thing that we should have made sure we should have checked to see if C prime of X is ever undefined. C prime of X is undefined. Note that this is C prime of X. It's undefined when X equals 0. But if you're airing 0 5-second holograms, that doesn't make sense to what we're looking for. So that's why we don't have to check that here. Okay? Now, our last example. Now, Hercules Films is also deciding on the price of the video release of its film, Bride of the Son of Frankenstein. Again, marketing estimates that at a price of P dollars, it can sell Q equals 200,000 minus 10,000 P copies, but each copy costs $4 to make. What price will give the greatest profit? This idea should seem familiar because we talked about profit before. Supply and demand, and that pops back up now as an application, just incorporating the new ideas that we've learned. So you should pause this, try this example, and then come back to this video and watch how we work through it. Okay? So hopefully you've taken some time to do that. Now let's start out with it. We want to know what price will give the greatest profit. So remember, revenue is equal to P times Q, and C here, our cost, it says it costs $4 to make, so our cost is 4 times Q. So remember, our profit is equal to our revenue minus our cost. So whenever we want to find out what price will give us the greatest profit, we're asking to maximize our profit. So we need to be able to know R and C in order to find that. So R is P times Q minus 4 times Q, which is C. So this is equal to P, we know is just P, it's your price. Then Q is this here. So we have times the quantity, 200,000 minus 10,000 P minus 4 times Q, which is 200,000 minus 10,000 P. Well, that's equal to, so now what you need to do, pause the video, make sure you distribute your P, and then you combine like terms, distribute your 4. So distribute your P to each term, then distribute the 4 or the negative as well to each. Doing that, we get 200,000 P minus 10,000 P squared minus 800,000 plus 40,000 P. So we distributed the terms. Now we combine like terms if possible. We get negative 10,000 P squared, and then we're going to have 200,000 plus 40,000 P. 200,000 P plus 40,000 P gives us 240,000 P minus 800,000. All right, so that's the equation for profit. Now, something to think about, and we need to know, for P and Q, for both of these to both be non-negative, or in other words, for both P and Q to be positive, P has to be greater than or equal to 0, but less than or equal to 200. Not 200, the 20. Okay? P has to be greater than or equal to 0, but less than or equal to 20. You might ask yourself, Dr. D, where in the heck did that come from? Let me explain it to you. So the reasoning here, so we need this, that comes from the following, because that would mean that P times 200,000 minus 10,000 P, this is just P times Q. That means that has to be greater than or equal to 0. Well, what does that mean? That means either P has to be greater than or equal to 0. That's focusing on this part. Or that means this part has to be greater than or equal to 0. So, or 200,000 minus 10,000 P has to be greater than or equal to 0. Okay? Well, this means 200,000 is greater than or equal to 10,000 P. Divide both sides by 10,000, and that gives you 20 is greater than or equal to P. So on one hand, you have that, let's see, you have P has to be greater than or equal to 0, but on the other hand, you have 20 has to be greater than or equal to P, or P is less than or equal to 20. That's where this comes from. And that's important because that gives us the domain. So if you need a pause and to go back and review that portion, make sure you do that. So far, we found our profit equation, we found our domain. Now we still have to find our derivatives so we can find our critical points. All right, since we're maximizing our profit, let's find P prime. P prime is equal to, remember, smiley face is our P. Now we need to differentiate P. Well, differentiating P gives us negative 20,000 P plus 240,000. Well, now we need to find our critical points. We find out where P prime is equal to 0. That means negative 20,000 P plus 240,000 is equal to 0, or negative 20,000 P is equal to negative 240,000. Divide both sides by negative 20,000. And that gives us P is equal to 12. Okay? Now, we also get critical numbers or critical points whenever P prime is undefined. Note here that P prime is always defined. So P equals 12 is our only critical point. So one thing to note, pause here. In example 2, if we look back at that example, back to our example, we check, we have P equals 12 is our only critical point. Now you can either use the first derivative test or you can use the other method. Again, you can use the first derivative test or you can use the other method. I'm just going to show you the other method as a refresher. So we can test our endpoints and your critical points. Remember, both methods work, first derivative test or this method. Choose whichever you like. But when you check the endpoints and your critical points, you're checking that in your function, not your derivative. So we're checking that into our profit. Okay, so P of 0, notice that 0 is an endpoint. We're getting that from here. 20 is also an endpoint, and then 12 is our critical point. So P of 0, we need to find that, P of 12, and we also need to find P of 20. Well, we're plugging that into our profit equation, so we're plugging that into smiley face over here. So if you plug in 0, then you have 0 here, 0 here, you get negative 800,000. Plug in 20, not 20, plug in 12 here. When you plug in 12 for P, you can write that out. When you plug in 12, you're going to get 1,840,000. And then when you plug in 20 here, you should get 0. So what this means is $12 will give P equals 12. The price equals 12. We'll get $12 will give the greatest profit. And that's it.